you take a shower or flush the toilet, what happens to the water? Water and waste wash down the drain of homes, businesses, and industrial facilities flows through a network of pipes called a collection system. According to the U.S. EPA, there are about 800,000 miles of collection systems in the U.S., along with 500,000 miles of private laterals, which connect properties to the sewer system. Water typically travels through pipes by gravity. Once pipes get too deep, a pump or lift station moves wastewater into a new section, and water moves downhill again. Many older cities have combined sewers that convey both stormwater and sewage. A large storm can overflow the sewer and greatly increase the volume of water reaching the plant. Wastewater travels to the 16,000 publicly owned water resource recovery facilities, commonly called wastewater treatment plants, that serve over 190 million U.S. residents. The first part of the treatment process is called the headworks. Influent screens filter out large debris like rags, cans, and other trash, represented by the yellow spheres. The removal of large debris helps keep pumps and pipes within the plant from getting clogged. The trash removed from the screens is collected and disposed of at a landfill. The goal of the headworks is to remove inorganic matter from the wastewater. Inorganic matter includes items like trash, sand, or gravel, basically material that did not come from a living creature. The next stop within the headworks is the grit removal chamber. Grit is made up of large, heavy particles like sand or eroded cement. Water flows slowly through this tank, keeping organic matter like food, waste, bacteria, or excrement in suspension, but giving the heavier grit a chance to fall to the bottom. As grit settles out, a rake runs along the bottom of the tank, sweeping the grit away. Removing grit early on is important because it is abrasive and can erode mechanical equipment. It can also build up in later treatment processes. Though not shown here, flow monitoring occurring in the headworks helps operators prepare for volume and velocity of water entering the plant. Based on this information, operators can add the proper amount of treatment chemicals and allow adequate time in each treatment process. Flow monitoring happens throughout the rest of the plant. After the grit removal chamber, wastewater flows into primary treatment. The first step is a set of fine screens that can remove even smaller debris. Again, the debris is collected and taken to the landfill. The main goal of primary treatment is to separate water from solids, known as organic matter. This differs from the headworks, which is designed to remove inorganic waste like trash and grit. Like the headworks, primary treatment relies on physical separation methods, such as screening and sedimentation, which causes sediments to settle out by gravity. Primary clarification is the next step in the treatment process. Wastewater comes up through the center of the clarifier. Water typically sits in the clarifier for 1 to 2 hours and becomes quite still. 90 to 95% of settleable solids fall to the bottom over time and are removed. 50 to 65% of suspended solids are removed. These are very small organic particles that float in the water column. Oil and grease floats to the top and is skimmed off. Cleaner water flows over the clarifier weirs as solids settle out. A rotating arm breaks the solids from the bottom of the clarifier into a hopper in the center. The solids skimmed off the bottom of the clarifier travel to the biosolids treatment process. The water now travels on to secondary treatment. This part of the process removes nutrients like phosphorus and nitrogen, which helps keep rivers and lakes clean. Algae thrive in waters high in nutrients. When bacteria feed on algae, they use up all the oxygen in the water, creating dead zones that cannot support fish or other aquatic life. However, nutrients are also a valuable resource, particularly for agriculture, and can be recovered through the treatment process. The first secondary treatment stop is the aeration basin. Unlike primary treatment, this part of the treatment process relies on biological action rather than physical separation. Blowers generate oxygen that is distributed through a network of pipes into the aeration basin. oxygen generated by the blowers is used by hungry bacteria, as shown in green. They feed on the solids, reducing their volume and removing nutrients. Next, water goes through secondary clarification, which works similarly to primary clarification. Again, solids are sent to the solids treatment process, and water moves on to be further purified. Some of the solids, known at this point as activated sludge, are sent back to the aeration basin. This activated sludge helps maintain healthy populations of beneficial bacteria that reduce solids and remove nutrients. The next step is an advanced treatment process that is often used to produce ultra-clean water needed for reuse purposes. The technique shown here is a membrane filter. It works by forcing water through very small pores. Only very small molecules can make it through the filter, so the resulting water is free of even very fine particles and even many microorganisms. Once water is passed through the filters, it moves on to the final step, disinfection. This step removes any remaining bacteria or other microorganisms that could cause illness. Chlorine disinfection is the most widely used method, but ultraviolet disinfection, shown here, and ozonation are also common techniques. The water is now virtually free of all solids, grit, and microorganisms, and can be returned to a receiving water body or used for a variety of other purposes, including, but not limited to, firefighting, cooling at industrial facilities, and irrigation. Back at the plant, the solids removed from the clarifiers travel to the solids treatment process. The goal is to turn them from solids into biosolids. The term biosolids is applied when treated sludge meets certain requirements for beneficial reuse. The treatment plant must reduce pathogens, odors, and lower concentrations of specific metals. The first step is to further remove water from solids and concentrate them. Treatment plants use a series of techniques called thickening and dewatering. The first step shown here is a centrifuge, which uses a spinning action to separate the water from the solids. The water that is removed goes back to the beginning of the treatment process, the headworks. Some bacteria, unlike those in the aeration basin, prefer places with limited oxygen or anaerobic environments. The next step in the treatment process is the anaerobic digester, which is covered to prevent air from coming in. The bacteria at work in the anaerobic digester reduce pathogens and volatile solids, which contribute to odors. The bacteria also make biogas, a mixture of methane and carbon dioxide, represented here by the pink balls. Methane is heated to produce steam. The steam is then used to power the turbine, and energy is created due to the turbine's movements. Some plants can power their entire operations using energy produced on-site, and some even sell electricity back to the grid. After the anaerobic digester, solids go through one last dewatering process, in this case a belt press. As the name suggests, water is squeezed out of the solids as they are pressed between two moving belts. The resulting sludge cake is collected in a truck and then disinfected. One method of disinfection is similar to composting, where the work of bacteria creates extremely high temperatures that destroy pathogens. Once disinfected, biosolids can be used in agriculture as fertilizer. Water and wastewater operators are one of the top 10 jobs Americans cannot live without, according to Reader's Digest. Operators control processes, make sure equipment works properly, and constantly test water and solids for compliance with regulations. The water sector faces many challenges, from urbanization to aging infrastructure. Yet a $1 billion investment in water infrastructure creates 40,000 jobs. The end result is a clean water environment for all of us today and future generations. Because water's worth it.